guys, today we are going to be discussing about CodeChef Starters 202 problem. Today, this contest was probably one of the easiest CodeChef contests so far. Yeah, I went down to day one and got back to day two, but yeah. We solved five problems over here. This totally eased down, and all these three were pretty difficult. So let's dive into the video.
So this is what's given, and the basic idea crux of the question is to basically find the hours after September 4, right? So let's say the given test case says phi over here. So phi is x and h is 10. So 10 hours past midnight on September 5th. So we have to basically find the hours after September 4th, right? So obviously we'll have to minus 4 over here to get the hours of the days. So when you do that, you will get 1. So this is 1 day, and we obviously know 1 day has 24 hours in it, right? So we'll multiply that. So x minus 4 into 24 plus the current hours, right? So this is basically the answer. So x minus 4 into 24 plus h. Input format expects x and h as two separate integers, and thereby we just take them using map feature, and then x minus equals 4 as I mentioned, x into 24 the current hours, and plus h, and yeah, all set. So this is question number 2, and it says that we have two values, right, given. That's x and y. X is the current value which you have the current score, and you have to reach 50. 50 is the value which you have to reach. That's the aim behind the question. And you have two dice, that's these two pairs of dice, and the start value is y. Usually in a normal dice, it's start value is 1, which we know, right? 1, 2, 3, 4, 5, and 6. But here it starts from y and goes up to y plus 5 value. Now, as I mentioned, our goal is to reach 0.50. And the trick over here, the edge case over here is that we should exactly reach 0.50. We cannot go more than 0.50. So the points which we'll have to achieve is 50 minus x. That's the value which you have to reach, because x is the current score which you have, and 50 minus x is the score which you'll need to achieve in order to reach 50. So let's check for some test cases. So these are the test cases, and if we can reach the 0.50 exactly without exceeding the value, then we can print yes, or else we can print no. So 46 is given over here, so we'll have to achieve 4 points, right? 4 points to reach the value 50, and the start value is y, that is 1. So if the dice starts from 1, it's obviously going to be 1, 2, 3, 4, 5, 6, because y plus 5 is the range value. Now, how can we reach 50 with this y value? So let's say it's pair of dice. So the value can be either 1, 1 or 1, 2 or 2, 1, like that. 6 possible cases are there, and it's obvious that we can surely reach 50. That is with 4 as the value which we'll have to get. So that can be either 1, 3 possible. Now let's check for the next test case. So 36 is the current start value, which means 14. 36 minus 50, that's 14, is the value which you have to achieve. Now the value of y, the current start of dice, is going to be 1. So it's obviously both the dice are going to be 1 up to 1, 6. So the maximum value which we can achieve from both is 6, 6, which is 12. So this is the maximum value we can achieve. But when we see 14 is the given value, and we cannot achieve it 14, right? Because our dice should be twisted or hit exactly once, and the maximum value which we can achieve by hitting it exactly once is 12, and 14 is obviously greater than 12, so it's impossible to achieve. That's why we hit a no. Similarly, 36, that's 14 again to be achieved, the next test case, and the start value but this time is 2, and it can go up to 7. Likewise, another dice will also go up to 7. So when we roll this pair of dice, we'll get 14 as our maximum value in a single turn, and it's equal, so we can print yes. But now there's a slight edge case to this question. So up to this, we understood that the point which you have to score is 50 minus x, right? And we just have to check if 50 minus x is less than or equal to the maximum value of dice, that is 1 plus 5 into 2, because there are two pairs of dice. So the maximum value which can reach is y plus 5 and two pairs of dice. So this is the maximum value which can reach, and it should be less than or equal to 50 minus x. That's what we have understood so far. But if you look at this particular test case, we have to achieve 22 as the score, and our start value of the dice is 14, and it can maximum go up to 14 plus 5, that's 19, twice, right? So if you think about it, the start value itself is 14. So every single time the minimum possible value which you can get is 28, because 14 comma 14, and 28 itself is greater, way greater than 22. So it's impossible to achieve 50 exactly, because our constraint is you should not reach more than 50. You should either exactly reach 50, like you should only reach exactly 50, right? So that's the problem. So the final conclusion of this problem statement comes down to just checking for two possible conditions. That is, if the maximum value, let's say score which we have to achieve is 50 minus x, then the maximum value, that is y plus 5 into 2, should be less than or equal to this, that is, let's say s, and the minimum value should be greater than or equal to that particular score. So s should be greater than or equal to the minimum value y into 2. If you check for these two conditions, and if it satisfies, you can print yes, else you can print no. So for this we take t, the number of test cases in a for loop, and then we'll have x and y, x being the current score and y being the start value of dice. We take it, split it in a map and assign those values, and then 50 minus x, that's the score to be achieved, is greater than the maximum, is lesser than or equal to the maximum value, and 50 minus x, again the score is greater than or equal to the minimum value. If yes, we print yes, else we print no. And yeah, all set. We'll just run it once and we'll check. Yep, works. Submit. Okay, and yeah, it's perfect. So this is the next question, question 3, and here it says that we basically have to buy n by 4 n flowers, right? And this n flowers should be bought with the minimum possible cost, and the conditions is that you can either buy 2 flowers for 4 coins, or you can buy 3 flowers for 5 coins. And obviously this is the best value, right? Because 5 by 3, that is 1 flower, will give you around 1.67, or else 4 by 2 will give you 2. So this is per flower value, and this is per flower value. So obviously this is the best value if you want to minimize the cost. Now I will first explain the most brute force approach which would immediately come to your mind, and that would run in O and time complexity. So immediately after looking at this, you will know that okay, I have to basically find the number of flowers which is divisible by 3, and then I can immediately print the value with the flower with those values. Let's call this as bouquet 1, and this is bouquet 2. So we'll have to maximize the value of bouquet 1. Let me give an test case as an example. Let's say it's 6. There are 6 flowers which chef wants to buy. So it can be bought in the form of 2 bouquets, right? Bouquet 1 and bouquet 2. As in 2 bouquets. Because it can be divided as 3 and 3. Both are divisible by 3. So the maximum value it will cost the chef is 10 coins. But let's say if the value is 5, that it can be separated as 3 comma 2, 3 flowers and 2 flowers, and this is obviously bouquet 1, this is bouquet 2, and then it would lead to 5 coins plus 4 coins, that is 9 coins. This is the most optimal value. So from this we clearly get an idea. We'll have to find the first value which is divisible by 3. So first we'll immediately, in brute force approach, we'll check if n mod 3 is divisible by 0. As in if n is divisible by 3, that if it's accounting to 0. If it is, it counts as one bouquet. So we'll divide n by 3, we'll multiply it by 5 because that's the total cost. Each bouquet's cost into 5, which will give the total amount of coins. Now, let's say if it's not divisible by 3, that is if we have 5, we can run a loop from 2 comma n, because always 2 will be one set of bouquet. We can't buy one as single flower. It can always be minimum value which can always be bought is 2. And also the constraints say that n is from 2 to 100. So we can run a loop from 2 to n and check if that value is, and another small observation is that it should skip 2 values. So it can either by 2 or 4 or 6. So that's the idea. So you can run a loop from 2 to n for every 2 flowers, and if it's divisible by 3, the current value, that's when you can stop the loop and print the total cost. I will give an example so that it's understandable. You'll understand the code base much easier when you see it. I'll give an test case as an example. So let's say n is 7 this time. It runs from 2 comma 7. So first iteration when I is equal to 2, we'll check if n, that is 7, minus 2, which is 5, is divisible by 3. It's not. Now we'll check in the next iteration, which comes to 4, because we skipped 1. So it will become 7 minus 4, which is 3, is divisible by 3. Oh yes, it is. It's divisible by 3. So we break the loop over here and we'll keep a count of the bouquets counted so far. So 4, right? So that's 4 flowers which are bought with bouquet 1 as the case. So that would cost 4 coins for each 2 flowers. So you can keep it as I by 2 because I is the value. So you can say the bouquet 1, that's I by 2 into 4, plus n minus I, because n minus I is what is divisible by 3, right? N minus I by 3, because that counts as bouquet 1 as mentioned over here, into 5 coins. So that's the idea. So this was the brute force approach, which was quite lame. Why? Because you can do this question in an O1 approach. Now why is it so? Because we surely know one thing for sure, that in the entire this looping process can be avoided, because we are again and again checking only for the possible value which is divisible by 3. So we are trying to get the maximum set which is divisible by 3, right? Which can directly be done by dividing the n value itself with 3. So when we do n mod 3, there are 3 cases which is possible: 0, 1 or 2. And if 0 is the value, if n is divisible by 3, then you can directly print the value as n by 3 into 5 bouquet into the total cost. But when it's 1, what does it mean? It means, let's say, let's think of a value, that's 4. So 4 mod 3 is 1, right? Now what do we do for this condition? Now when you see 1 as the remainder, that means you'll have to remove one set of bouquet. That's 3 flowers we'll have to remove from the current value of n. Because if we remove 3, as we already have 1 as the remainder, and if we remove 3 other flowers, it will become 4. And at any point you will only need to remove 4 to achieve the most optimal value. So if you do n minus 4 into 3, that is divided by 3, plus there are 4 flowers which should be counted now. For that, 4 flowers is counted as two bouquets of two flowers, right? So we know these two bouquets cost 4 coins each. So that is 4 plus 4, 8. So what you do is n minus 4 by 3 into 5 plus 8. That is, let's keep a bigger example. That is 10. So you have 10 flowers, and the maximum value which is divisible by 3 you can take over here is 9, but you'll be left with one flower to buy as extra, but you cannot buy one flower separately. You can buy only maximum of 2 flowers, right? So what can you do for this condition? As I told, you can remove 4 flowers from this. So 10 minus 4 will become 6. So this can be bought as 2 bouquets of 5 coins each, and you have left with 4 flowers which will cost you 8 coins, because 2 to 4, that is 2 into 4, that's 8 coins. So this is the basic formula for it. So we check the condition for n when the remainder is 0 and when the remainder is 1. Now what if the remainder is 2? Let's say 8. So the maximum value which is divisible by 3 is over here 6, which leaves you behind with 2 flowers, and 2 flowers can be bought with as one bouquet with 4 coins, right? So that's the answer. You do n minus 2 if the remainder is equal to 1. Then you can do n minus 2 by 3 into 5 plus 4, because it's only 2 flowers. So that's the idea. So this is the final algorithm. That is, find the remainder. If remainder is 0, then directly print n by 3 into 5. But if it's 1, remove 4 flowers, divide by 3, count the total cost for that set of flowers, and plus 8, because you have 4 flowers left. And finally, if it's 2 as the remainder, then just do n minus 2 by 3 into 5 plus 4, because 2 flowers are left. So this will give you the right answer. So yeah, this is the brute force approach which I mentioned earlier, and it certainly works, but it's not a good one. So let's move on to the optimized approach, which works in one. So t, the number of test cases what we take, and n is the integer value, the flowers. Remainder we'll take n mod 3, because we'll have to take the minimum possible value. If remainder is equal to 0, I told let's divide it into a set of bouquets, multiply by 5 the total cost. If remainder is equal to 1, we'll first subtract 4 flowers, 1 extra flower, and 1 set of bouquet, that's 3 flowers, and then we'll be dividing that set of flowers, that's n minus 4 by 3 into 5. That gives the total cost for one set, and those 4 flowers which were set left will be 2 bouquets, so 8. And then if n remainder is equal to 2, n minus 2 by 3 into 5 plus 4 will give us the right answer. So when we submit it, yep, all set, works. So here's the next question, a pretty interesting question actually. That is, you're given an array, and you'll have to I'll explain what you have to find. So let's check with our test case. Let's say the test case is something like 5 3 4 2. You'll have to find the median. Now how do we find the median usually? That is, we first sort the array, so that's going to be 2 3 4 and 5. Now we'll check the median value. How do we check the median value? We choose the middlemost value. Here in this case, it's, by the way, we should know that n, that is the size of the array, is always divisible by 2. So a median for finding which of n size which is divisible by 2 is taking those two middle values, adding it, dividing by 2. So in this case, with 3 plus 4, 3.5 will get the median value. But according to their description, they have a different way of explaining median. That is, they're just saying you to take the leftmost value of the median. That is, you have 3 comma 4, take the leftmost value. That's take 3, right? Now the question says you'll have to find a subarray such that it contradicts the value, as in there's a person and he finds the median value according to description, but he forgets to sort the array. So this is the sorted array and this is the unsorted array, and for him when he takes this unsorted array, the median value which he gets is 3 over here. Again, okay, by luck he has got the same value, 3 and 3, both are same. But that's exactly what we don't have to find. We have to find a subarray which contradicts the actual median value. As in, when you sort that subarray, that particular subarray, and then when you find the median of that subarray, let's say the median is x, and when the person does not sort that subarray and finds the median of the value, let's say that median value of y, they should not be equal, x should not be equal to y, and that's when you'll have to return the indices, the start and end range of the subarray. That's the question. Let me explain with a clear example. Now here, if you check, if you take 4 comma 2 as the subarray, you take 4 comma 2 as the subarray, you sort it. Usually to find the median value we sort it. So 2 comma 4, take the leftmost value, so 2 you will get. But according to that person, he does not sort the array and he just gets 4 as the value. 4 is not equal to 2, so he'll just return the indices. What's the indices over here? It's an 1 based indices, so 1 2 3 4. So the person will return the value as 3 comma 4. That's the expected output. Now let's look at another test case given in the question itself. So this is an array which is given. Now when we look at the array, now the most brute force approach would be, the brute force approach for this would be first generating all the subarrays and then sorting every single subarray and then checking the median value. So you run a loop from 1 to n, 0 to n. So for I goes from 0 to n, and then another loop for j goes from I comma n. And also you'll have additional space complexity also to store the unsorted and the sorted subarrays. So let's say it's x is equal to subarray, y is equal to some subarray, and you have to store each of them inside. You store x, you store y, and then for each addition inside the array you sort it. Also, as I mentioned, the subarray should be even. That's only we take, then only we take the even subarray, or else we just skip. So you check if the size of the subarray is divisible by 2 to check if it's even, and then you sort it, and then you check the value. So space complexity for this is on, and time complexity is even worse, way worse, that is n square for checking, as in generating all the subarrays, and n log n for sorting each and every subarray, which pours down to n cube log n. We don't want it. Why? Because this can be solved in O1 space and On time complexity. How? Here we go. So we got to know one thing clearly, right? That is, the subarray size should always be even. That is one. And another big clue which is left behind is inside the question is that it can have any possible answer, but it should satisfy the condition. As in, it can be subarray of any size, it can be 2, 4, 6, 8, anything, but it should be divisible by 2. So that's the biggest ease down of the problem statement which has been done. So let's say we take 5 comma 4, right? We only need to check subarrays of sizes 2, because if it's unsorted, it will give us the greater value possibly, and if it's sorted, it will always give you the minimum value of size 2. That is, let's say 1 comma 2, the original subarray is 2 comma 1. Here, without sorting, you get the median value as 2, but with sorting, the actual median is going to be 1. Both contradict, so you can directly return the indices. Likewise over here, when you check 5 comma 4, that's just by checking if the current value is smaller than the previous value. If it is, just directly return it. So why? Because 5 is the median value which the person gets, the chef gets, but 4 is the actual median value because you sort it and take the leftmost value. So you can directly return 1 comma 2. So the algorithm is so simple, just a little bit of thinking was needed. So this is the basic idea. We just run a loop from 1 to n and we check if the current value is smaller than the previous value. If it is, we print I comma I plus 1. Why? Because it's 1 based indexing, as I told you. So if it's gonna be let's say 5 comma 4 5, right, we saw. So actual indexing is 0 1 2, but we start from 1, and yes, 5 is greater than 4. The previous value is greater than the current value, so I is currently over here. So 1 comma 1 I plus 1, that's 2. So in 1 based indexing it's correct, 1 comma 2, and then we break the value because we need only the first value. So that's it. But what if we don't get the value? There's no subarray which gives such a value, or when it's sorted 1 comma 2 comma 3 comma 4, it's always going to give the correct median value, right? In that case, you just keep a flag for checking. So if we find a value, we keep a flag f is equal to 1, and it's not going to print anything, right? Because all conditions satisfy. In that case, f is equal to 0. So we just check if f is equal to 0. If it is equal to 0, because f is equal to 1 and it breaks if it satisfies, but if it's not, we just print minus 1. So that's it. So yeah, we run a t times loop for the number of test cases, and then what's the input? Okay, yeah, and the number of the size of the array, I mean, and then we take the array by taking its values, and then we'll be adding a flag to check if we got any satisfying subarray or not. So we'll set it to 1, and now we'll iterate inside the array starting from 1, because we're going to check the previous values. So we'll check if the previous value is greater than current value. If yes, we found a subarray which satisfies the condition. So I comma I plus 1, which indicates 1 based index and then we'll just set the flag. If no value was found, so flag won't be set, right? So minus 1. Yeah, I guess we can directly submit it. It should be working. Yep, works. Min-max dex, the easy version of this problem, and this easy version literally makes it so easy because q is 0. I'll explain what the problem is. So you're given an array and that's a deck, right? And there are 2 players, Alice and Bob, as always. So Alice can put it at the either ends of the deck. Bob can do as well the same thing. And here's the twist: Alice always starts. Every single time she's the one who starts the game, so she can place it anywhere at the end or the start, and Bob can also do the same, place at the end or the start. But Bob is always trying to bring Alice's score down. Alice is trying to maximize it. Now you will have to get the maximum value from either of these ends, the minimum of these 2 ends, such that the value is maximum. I'll explain with a test case to simplify it. So this is the few test cases given in the question. So 1 2 3, right? Now Alice is going to start. As Alice is going to start, she takes 1, and as the deck is currently empty, she can place it anywhere. Let's say she is placing at the start, so 1. Now Bob wants to minimize the score, and here there's not much data. So let's say he's placing either over here, either over here, doesn't matter. So he places over here. Now Alice can place anywhere. But where if she places, it's going to maximize her score, because we either know they are going to take the minimum value from these 2. So either she can place over here or she can place over here. Let's say she places over here. The minimum value of the start and the end is going to be taken. 1 is the minimum value if we place it over here. But what if Alice places it at the start itself? Then the maximum value, which that the minimum value from these 2 is going to be 2. 2 is greater than 1. This one optimization has maximized her score. So you get 2 as the answer over here. Let's check for 1 to 2. So Alice places, Bob places anywhere because it doesn't matter. No, Alice places over here. She can either place over here or she can either place over here. But the right thing to do would be placing over here because she'll get 2. Minimum of 2 comma 2 is 2. That maximized her score. Else she would get 1 because if she places over here, it would become minimum of 1 comma 2, which will become 1. So 2 is the correct answer by placing it at the start. Let's check for 3 5 1 3. Now the game has hit a bit higher. So 3, she places, Bob places it anywhere. 3 4. Now where should Alice place? Obviously she should place, the first idea we get over here is to place it next to the minimum value. 3 is the minimum value. She'll place it over here. 1, Bob places it. Where will Bob want to place it? He will always want to place it next to the maximum value because he wants to minimize the score. 5 comma 4, which is maximum? 5 is maximum. So Bob will place it over here at the start 1. Now again 1 comma 4. Again, as I told, Alice will want to place it in the minimum value position because it doesn't matter. Even if she gets, let's say, okay, 1 was over here, but her value which she got was -1. Now you might be like, okay, why are we placing it next to the -1? Because it's anyways going to be lower, right? But isn't it obvious? Because we can it's a deck, we can only place it at the start or at the end. So obviously we'll have to choose one position. Why will we choose the minimum value? Because that's the most optimal idea. So 1 goes over here. So 3 will go over here. 3 and 4. Which is minimum? 3. So that's the answer. 3 4 2 1 5. A final test case. So by now we have got 2 ideas in our mind. The only 2 ideas is, if Alice is going to play, she will place the value next to the minimum value. And if Bob plays, he is going to place it next to the maximum value. He wants to decrease the value. Let's check with final test case 3 4 2 1 5. Alice places, Bob places, anywhere, doesn't matter. Now Alice is going to place next to the minimum value 2. Bob places on the maximum value 1. Alice places next to the minimum value, that's 5 over here. Now what if Alice places it at the start? 5, minimum of 5 comma 1 is going to be 1. But since he placed it next to the minimum value, it's going to be 2 because minimum of 2 comma 5 is going to be 2, and that's the answer. That's basically it. So the algorithm comes down to, so it's quite obvious, right? We only need to keep a track of the minimum value and the maximum value. That's the latest minimum and the maximum value. So we don't even need a data structure to store all these values. Just 2 variables is enough. So, but if we use a data structure, it's going to totally ruin our time complexity because we'll have to continuously insert it at the start and insert it at the end. Inserting at the end is not a problem, but in any language, inserting at the start totally revamps the entire array by inserting, because it would have to shift every single time, right, to the position. So that's why we'll only keep 2 values, that's x and y, and x will store the first value and y will store the next value, that's AR of 0 and AR of 1. Why? Because the array size is always going to be greater than 2, greater than or equal to 2. So we'll run a loop from 2 to n, and if I mod 2 is equal to 0, that is if it's the even movement, that is Alice's movement, because Alice is always going to start. So either she'll go in 0, or she'll go to 2, or she'll go to 4. That's in the 0th iteration, 2nd iteration, 4th iteration, 6th iteration is only when she's going to play. So this is Alice's turn, right? And what did I say? In Alice's turn, she'll place the value next to the minimum value. She'll try to place the current value next to the minimum value. So we are storing x and y, and if x is smaller than y, she'll store the current value in x, else she'll store in y. Now in odd turns, That's when I is equal to 1 or 3 or 5 and so on. What did I say? In Boston, he'll try to minimize the value of Alice's score. How will he do that? By placing the current value next to the maximum value. So if x is less than y, that if it's y is the greater value, he will keep y as the current value of iteration ARR of I. Else x is equal to ARR of I. So that's it. So I hope you all understood it. So let's dive into the code base. Yeah, we take t, the number of test cases, and then n comma q, we map those integers. N is nothing but the size of the array. Q is not really taken into account because it's 0 always, as it's a minimum version, easy version of the problem. And in ARR, the size of the array, x comma y will be the first value of the array, y will be the next value of the array, second value. And we run a loop from 2 comma n, and if it's an odd iteration, that if it's Bob's turn, anything and operated will 1 signifies it's like an odd number. So if it's satisfying that particular condition, that it's Bob's turn, then as I mentioned, the value which will be the maximum will be set to the current value. So here, if x is greater than y, x will be set to AR of I, else y is equal to AR of I. Then again, if it's an even iteration, minimum value will be set as the current value. So if x is less than y, x will be set, or else y will be set as the current value, and then we'll simply print the minimum of x comma y, and then that should give us output. So yeah, it matches, and well, it works. Okay. So that's for the video, guys. I hope you enjoyed the video and understood everything clearly. If you have any doubts, feel free to drop the comments. I'll surely clear it down. And that's pretty much it for the video. Well, please, I would love if you drop a subscription, but yeah, it's totally optional, up to you if you enjoyed it. And see you until next time. Signing off now, the Prajna.